Hi everyone, today we're solving problem 24. Here we have the problem. We're supposed to find the millionth lexicographical permutation of the digits 0 through 9. The lexicographic permutation is all of the permutations possible with those digits sorted in lexicographic order, and we're supposed to find the millionth one of these. So for example, here we're given the lexicographic permutations of 0, 1, and 2. So this problem, what we're going to do is we're going to, at each step of a loop, figure out which number is next. So we're going to start by calculating the first number in our answer, then the second number, then the third number, then the fourth number. Let's do a quick example to see how this works. So we have these numbers, let me copy them into a comment in our code. What we can see is, let's say using zero-based indexing, that we wanted the number at the second index. So here's 0, 1, second index, and what Project Euler would call the third number, because they use one-based indexing. What we notice is that for each first digit, there are two numbers. So there are two lexicographic permutations starting with 0, 2 starting with 1, and 2 starting with 2. This isn't just a coincidence. The reason is because once you select one number, the number of remaining possibilities is the original length minus 1 factorial. So in this case, it's 3 minus 1, 2 factorial. So that's why there are 2 every time. So we can use this property to jump to a specific number because we know the size of the groups at any moment in time based on how many possible number choices we have remaining. So start implementing this, and then we'll get a better sense of how this is going to work. So we're going to do def nth permutation. We can take n of type int, and again, this is using zero-based indexing. And we can take digits of type a sequence of int, which is the remaining digits we have to use. So first of all, if our digits.length is 1, that means there's only one digit left. We know there's only one permutation with one digit. It's just what digits is already. And in this case, we're going to be returning a sequence of int where every int represents one of the digits in the final number. Otherwise, what we're going to do is we'll start by calculating which group the next the sub-number is going to be part of. And this is using the factorial logic that we found earlier. So we can do val, I guess we can call this smaller permutations, which counts the number of permutations after picking the next number. And the way we calculate this, we just do digits.length minus 1, and we want to factorial this, so I've wrapped this in parentheses. And since factorial, the implementation is copied from util, I'll actually need to import that. Import util._. And since this returns us a big int, but we know our numbers are small enough that we can safely convert this to an integer. So this gives us the size of each group. Now to figure out which group we need, and with that we can know which digit to use next, we do val group index is going to be the n, which is the index that we want, so n, and we're going to divide that by the number of small permutations. So for example here, if we wanted at index 2, we would know to check in group 1, because it would be 2 divided by 2, and that tells us to look in this group. And we need to calculate what index within this group the next digits, the number is at. So we can do within group is going to be, and here, instead of dividing, we just do modulo, which gives us the remainder when dividing n by small permutations, which is the size of the group. So for example, if we were doing 0, 1, 2, 3, 3, if we wanted to find this one, this would be 1, which tells us that within the first group, that would be group index, it's at the first index. And now what we do is we're going to first calculate the digit that we just found, which is digits at group index, and we're going to append this to nth permutation. Now our n is within group, because we know that's the index within the group that we just chose. And digits is going to become digits.filter_not underscore equals digits at group index. So basically we're removing the digit that we just picked out of the entire digits sequence. And that's it. Now if we want to print out the answer, we want the millionth one. And since we're using zero-based indexing, we want, in this world, the 999,999th one. And digits is just a range of 0 to 9. And since ranges are also sequences, we can just use this directly and don't have to do any conversions. So I can run this, and we need to make string this. So this gives us the vector which contains each of the digits. Now we can do make string, and we don't even need this because make string by default uses, just appends all of the elements directly next to each other, and we get our answer. So that's our solution for problem number 24. I'll see you next time when we solve problem number 25.